Today in class we looked at how to draw trig graphs, and the first one we looked at was if you wanted to draw the graph of the equation y equals sine x, and what you would need to do is get some coordinates. So in class we picked some numbers for x to be, and you can see from my table up here we've picked multiples of 30 right the way up to 360. Normally when we're looking at graphs we look at between 0 and 360 degrees. Then on the calculator we worked out the sine of all of these numbers. So we typed in sine 0 and we got 0. Then we typed in sine 30 and we got 0.5. Sine 60 is an irrational number, and it turns out to be 0.666 continues, so we rounded it to 0.7. Sine of 90 was 1, and so on. So we typed them all in the calculator, and then we plotted them on the graph paper, as you can see below. So when you plot 0, 0, down there, 30, 0.5 was there, 60, 0.87, etc. And what we found was when we plotted them, they make this nice smooth curve, and this is the curve y equals sine x. So it starts at 0, it reaches its maximum up here at the turning point. The turning point's at 91. Then it goes down and it hits 0 again at 180 degrees. Then it goes down below the x-axis, and its minimum is at 270. And that's minus 1, and then it continues on up to 360. Now if you plot this graph in your Desmos app, you'll find that the graph doesn't actually stop here or begin here. It keeps going forever and ever, repeating. So then we said if we were going to do cos x, if we did the same thing for cos x, then this is the graph that we would get here. So as you can see, cos x is very similar. The maximum's at 1 and the minimum's at minus 1, and the difference is it starts up at 1 and then goes down, whereas sine x starts at 0 and goes up. It goes through 90, its minimum down here is at 180 degrees, and then its maximum is at 360 and at number 1. So, there's a couple of things we need to look at when we're looking at these graphs. They're written over here, the period. The period is how many times, or how many degrees in one revolution of the graph. So sine x and cos x both have a period of 1, because this is one full revolution of the graph in 360 degrees. And what we'll go on to look at is what happens if there's more than one, if maybe it's a bit squashed in and it's going up and down like this, and that's when the period changes. We also looked at the amplitude, and the amplitude is kind of like the height of the graph. So how high is the graph from the x-axis upwards? And the proper definition of that, it's half of the distance between the maximum and minimum. So the minimum's at 1, so the minimum's at minus 1, and the maximum's at 1, so the half of that distance is 1. So the amplitude of the sine graph is 1. The cos graph is the same, the amplitude of the cos graph is 1, and the period of the cos graph is 360 degrees, because we get one full revolution in 360. Tan is a bit of a stranger graph. What we found when we plotted tan x was that for the value at 90 and 270, if you try and type in tan 90 or tan 270 on your calculator, you'll find that you get an error message, and that's because tan is an undefined function at those points. In other words, it's impossible to work it out. So what happens with the tan graph is it starts at 0, it goes up the way, and then just as it's approaching 90, it just shoots off high, and it never actually stops. It keeps on going right the way up to an infinite number. But it never actually quite reaches 90, it just comes really close to it. And then just after 90, very close to just after 90 is where it starts again, and it comes right the way up from minus infinity, right the way up. It goes through 180, and at 180 its value is 0, and then it repeats the same thing again. So it shoots the whole way off, right the way up here. It comes really close to 270, but it never actually reaches 270. It's undefined at 270 degrees. So it comes really close to it, and then it starts again really close just after it. And again, just like cosine and tan, just like cosine and sine, the tan graph keeps on going forever and ever. So if you plotted it in Desmos and squashed it in, you would see that it's just a series of these little lines, squiggly lines going side to side the whole way in both directions.